So it's time to start talking about imaginary numbers, and if they actually are imaginary, question mark? Stay tuned. Alrighty, imaginary numbers, where are they coming from? Tell you what, I'm going to start you off kind of easy and slow here. I'm going to ask you guys to do a couple of things, and then after that, we'll kind of pull it all together, and we'll get ready to use them in quadratics in a little bit. So, first things first, hit pause in a second and go through and do these. And if there's a part of the problem that you're not sure about or seems a little weird, just kind of break it off to the side and see what you come up with. So here the goal would be this, and I'm hoping that on the square root of 72, when you go through and do this, you're saying, oh, wait a second, that's like 36 times 2. So I can pull out 6 root 2. And again, this is just like what we did before. Over here, you see the square root of negative 81. Now, I know, hey, teachers have told us for years we can't take square roots and negatives. Not entirely true, but let's think about it this way. What is the problem with that negative? Well, that's the fact that we have a negative. So why don't we, what would happen if I broke it down into that? Then what would you do? Yeah, you're right. This would turn into 9 square root of negative 1. Huh. Interesting, right? So do the same thing with this last one. Try to break that down. So over here again, what you'd end up having is that we would end up having, okay, this is, I've got a 49, I've got a 2, and I have a negative 1. So the square root of 49 is going to be 7. I have the root 2, and then I'm going to leave square root of negative 1 over there because it's the problem child. We're just going to set it aside, and we're not going to just... Everything else seems to work when we don't have that there, so we're just going to pull it out. And that's actually what we do. Now, question is, why do we need this? It's used in electronics quite a bit. So if you like your iPhone or if you like the internet, this is all worked out with electronics and electrical engineering and stuff. So that is where all of this came from. So what the definition of the square root of a negative number. So what we end up doing is that we're going to break this down just like what we did into the square root of negative 1 times whatever we're taking the square root of. Now the question is, this is a lot to write here, right? Lots going on here. So what they ended up doing was, let's go ahead and do the following. We're going to say, okay, we're going to define I squared to be a negative 1. And I is going to be a variable that, as somebody asked earlier today, you're never going to be able to use again. Not that we use it a lot, but the reason why we don't use it a lot is because it is used here for imaginary numbers, which is going to be a lead into complex that we're going to be doing next after this. And so everywhere you see a negative 1 now, the square root of negative 1, we are going to write I in its place. And so over here, by definition, if I have the square root of negative, or the square root of the opposite of A, that is going to end up equaling the square root of A times I. And again, that I is not underneath the radical. But again, so this is going to be easier to write. We're not writing down the square root of negative 1 all the time, et cetera, et cetera. And the history of how I came to be is rather fascinating. I'll leave that to you. Or if you're in class, we can talk about it later. Now, this is extremely important. This is the one part that a lot of kids who are like, I got this, don't worry about it, end up missing. Okay, we need to use this before we use anything else. Reason being is this. When I do the square root of negative 4 times negative 9, by order of operations, I'm going to do that, and I'm going to get negative 4 times negative 9, I get square root of 36, and that's going to end up being 6. But when they're in separate radicals, you cannot combine. These are not the same. Because you have to, because of order of operations. Yeah, okay, triple O squared, by the order of operations. So what we need to do here is that we would break this down into, and again, this is going to be more than you need to write down. That's going to break down into 2I. And then I'm going to multiply that down by the square root of 9, again, square root of negative 1, so that's going to turn into 3I. So when I multiply 2I times 3I, everybody's like, isn't that just 6? And the answer is no, because I'm going to get 6I squared. And then after that, what's I squared worth from before? Oh, wait a second. It's equal to negative 1. So this is going to equal 6 times negative 1 and that's going to be negative 6. Okay? I have seen over the years people try shortcuts, people try to come up with it. The best way to do this without making any mistakes is to just go from here to here. Okay? Don't try to be a hero. Do what's asked of you. And again, you don't need this step. You don't have to worry about that one. But by doing it that way, people make less mistakes and life is good. So let's see how it works in here. So take a couple of swings on these. Again, I would pause it here, try to do what you just learned, and then let's check your work. Hey, welcome back. I'm glad you tried. So anyway, so if I'm doing this, a couple of things. So again, this is going to be square root of 21 times I times the square root of 21 times I. So then I'm going to get 21I squared because the square root of 21 times 21 is just 21. I get negative 21. Now you could also probably make the case I could go straight here because again, remember root, you multiply a root by itself, it's whatever's on the inside. Just don't lose that negative. Over here, a little interesting thing, I'm going to break this down into root 5 times I times, and because of the way the 30 is broken up, I'm going to go ahead and break it up into, I know there's a root 5 in there somewhere. So this is going to turn into, theoretically, I squared root of 5 squared root 6. So the I squared is negative 1, the root 5 is going to be 5, the root 6 is going to stay, and that's your answer for that one. Division works the same way, because guess what I divided by I is? 1. However, you do need to rationalize it, so if you only have i's in the denominator, you will have to deal with that. So take a swing at these two. All right, so welcome back. So again, breaking these up, you're going to say, all right, I know I've got root 3 here times I. Up here, I've got square root of 42, which I could break into, what would be 3 and square root of 14. So then, in this case here, the i's are going to divide out. Those go away. These are going to go away. And I'm going to get square root of 14. Now, Mr. Hayes, what happens if I don't change the square root of 42? Well, if you don't change the square root of 42, you will end up rationalizing this, right? Which is fine, and then it'll take care of itself. So you'll be able to get rid of some of that stuff that way. Now notice here I don't have i's in both spots. So on this one, I'm going to have, so this breaks down into negative 1 times 9 times 7. So, and this is square root of 3 times 7, so I could break it up that way. So let's do that. So square root of 9 times the square root of negative 1 times the square root of 7. I'm putting all the stuff that I know I'm going to simplify out front. And then I'm going to do, okay, square root of 7 times square root of 3 down here on the bottom. Why am I breaking that one up? Because this, the 7s are going to go, the square root 7s are going to go away. And why make life harder for ourselves when we don't need to, right? Square root of 9 is 3. Square root of negative 1 is I over root 3. So now you do have to go through and rationalize this. Multiply through by root 3 over root 3. 3 root 3, I over root 3. I'm sorry, that would just be 3. 3's divide out, so my answer is just going to be root 3 I. Make sure the I is not underneath the radical. Some people will ask something along these lines where they would say, well, wait a second, Mr. Hayes. I know root 3 can go into 3 because that's just going to be root 3 squared. And that would be perfectly acceptable. So then I could just go, actually I can just put the arrow here. That would just go straight into that. And that would be okay too. But again, just be careful. If you when in doubt, take the extra 10 seconds, write out that one extra step. It's not going to hurt you. Now, what happens in this case? There is a pattern that you will go through and see. So what I want you to do is pause this here in a second. And I just want you to start simplifying I to the third and I to the fourth. And just see what happens. And come on back. All right, so I'm hoping you saw this. Okay, I to the third is really I squared times I. Why does that matter? Because I squared is negative 1. So I'm just going to get negative I, or the opposite of I, out of that one. What happens when I have I to the fourth? You've got two things. Well, I've got I squared times I squared. What's that? Oh, it's a negative 1 squared. What's that going to be? It's 1. So notice here already, I never have. I have I here. This is negative 1. I have the opposite of I have 1. There's no reason. So I squared, I third, I to the third, I to the fourth don't exist because I can always simplify it. And that's always going to be true. So when I get over here to I to the fifth, oh, look, that's I to the fourth times I. This equals 1. So that means this is just going to equal I. Nice save there, huh? It's just going to equal I. I to the sixth. You can have I to the fourth times I squared. Oh, wait a second. That's just going to be 1 times negative 1. So my answer is going to be negative 1. I to the seventh. Oh, that's I to the fourth. I squared times I. So guess what? That's just going to become the opposite of I. I to the eighth is I to the fourth squared. That's going to end up being negative 1 squared, which is just 1. Sorry, that's not going to be negative 1 squared. That's going to be positive 1 squared. Apologies. And this pattern is going to hold true. Okay? So in every set of 4, when I get this, this is actually I to the 8th times I, so that's just going to be I. I to the 10th, so again, I can take 8 off. That's just going to become I squared, which is just going to end up being negative 1. I'm going to get the opposite of I. I'm going to go through and get 1. And that's going to continue. What you can do is this, and there's 2 different ways to do it. This is the way that I think works the best. How many I to the fourths do I have out of 32? Okay, how many left over? So once you do that, this whole thing equals 1. So I'm just going to get rid of it. So that means this whole thing is just equal to I. How about I to the 15th? How many I to the fourths do I have in that? How many left over? This is going to equal 1. I to the third, we know is I squared and I, so that's going to be the opposite because of the negative 1 and I. Now what do we do with negative exponents? Same thing as we did before. This is technically 1 over I to the 5th. So that's going to be 1 over I to the 4th times I. This becomes 1. So I have 1 over I. Now know that you still have to rationalize this because I is an irrational number. It's a square root. So I'm going to multiply that by I over I. So I get I over I squared. And there's probably more steps there than what you need. And I to the negative 14th, same exact thing. So that's going to equal 1 over I to the 14th. Now in this case, and people catch on pretty quick, if it's odd, it's going to have an I in it. If it's even, it's going to be 1 or negative 1. Because you have an even power, so that means you have I negative 1, or you have square root of negative 1 squared, so that's always going to not leave a radical. So in this case here, it's going to be 1 over, this becomes a 1, I squared is negative 1, so I get negative 1 that way. Okay. Anyway, I hope that's enough to get you guys started. That should be, at least for my classes, help you with the homework for today. Starting next week, we're going to say what happens if we're adding things to this and go from there. So anyway, hope that's helpful. We'll talk to you soon.